very much. Good afternoon, everybody. So, again, my name is Ken Simpson, and I'm one of the latest in a long line of entrepreneurs who have decided to quit their day jobs in order to fight spam for a living. So before I get started, I want to thank you all for attending this talk. I think USENIX is a really fantastic organization, and I'm really grateful to have the opportunity, and I feel honored to have the opportunity to talk to this audience in particular. And by the way, if anything goes horribly wrong with my presentation, bear with me. This is a new setup for me with this laptop. So this afternoon, my goal is to educate you about the economic system that drives spamming behavior and how we can fight back against spam by interrupting the economic system that is behind spamming behavior. I'm going to begin with a very brief history of spamming, mostly because it's interesting, but also because I think it's important to show you how we got to today's spam reality. After discussing the history of spamming, I will discuss my theory of spammer economics. In other words, I'm going to answer the question, why is it that spammers continue to spam us? And finally, I'm going to show you a bunch of interesting, or I suppose potentially interesting data showing how it's possible to really cut down on spam by providing behavioral barriers which reduce the profitability of spamming. If you have any questions, as I anticipate you probably will, I think we'll have quite a bit of time to answer them after my talk is finished. And I should also mention that there's going to be a bird of a feather session tonight on the topic of anti-spam, and there will be free beer provided for those of you who want to improve your social lives by talking about spam with your colleagues. This is my second LISA conference. The first LISA that I attended was way back in 2000 in New Orleans. If any of you are old enough to remember the year 2000, and it looks like some of you might be in that range, you will remember that spam was a curious and infrequent phenomenon back then. I remember how we used to forward spam messages around the office when a particular humorous one arrived. In 2000, I was at ActiveState, which was building a software package called PerlMX. PerlMX was basically mod Perl for SendMail, and if you don't know what mod Perl is, don't worry about it, it's not that important. The idea was that email was going to be used to host all kinds of new services, and that people would need a highly scalable and flexible platform on which to deploy email-based applications. Well, as it turns out, PerlMX didn't end up being a very successful application platform, but it did become a very successful anti-spam product. You see, after the dot-com boom ended, spam started on this exponential growth trajectory. The most popular example application that shipped with PerlMX became this very simple regular expression plugin that let you filter email messages based on their content. And customers were writing their own spam filters that kind of derived from this example plugin. Well, anyways, you can see how things went from there. ActiveState saw the potential of the spam problem and improved this example file into a complete, fully blown enterprise anti-spam system. So in 2003, ActiveState was acquired by a UK security firm called Sophos. And after ActiveState was acquired, I got together with some other engineers from ActiveState that I'd worked with, and we decided to start MailChannels because it was our belief that the approach that everybody was using to fight spam, which was really using heuristic rules to analyze the content of messages, we didn't see that as being particularly scalable as the volume of spam increased. So we wanted to start a company and see if we could figure out other ways of solving the problem. So I'll get back to what we came up with a little later, but for now let's take a few slides to look at the history of spam. And for scholars out there, I apologize, I'm not an academic, and so if I put something in the wrong year, please just understand it was my intention to get things right. So I didn't want to put this slide up, but I thought for completeness I really ought to start my history of spam by going right back to the beginning. The first spam ever sent was sent in May 1978. It was a somewhat innocent message from Digital Equipment Corporation, probably from someone in the marketing department, to a long list of recipients advertising a seminar that they were doing in California about some new computer system. What made this message spam was that it was sent without anyone's permission. The recipients were essentially scraped from 1978's equivalent of Usenet, much as email addresses are now scraped from websites. In any case, this message got things started, and spam certainly hasn't looked better since then. So some of you will argue with me over this point, and I encourage you to do so this evening at the Bird of a Feather session. But in my opinion, spam wasn't a major problem until 2002. Why 2002? Well, I think the answer is probably that by 2002, enough people had email, and by people I mean mom and pop, sitting in the basement using AOL, that there was a critical mass that could make spamming highly profitable. Also, and this is my own pet theory, in 2002, a lot of software developers were out of work, and what would you rather do? Send spam for a living or work as a barista at Starbucks? Anyhow, in 2002, spamming was still legal in most countries, which meant that spammers didn't have to hide from the law. Spam was sent from Linux servers and legitimate co-location facilities. Large venture-backed companies like Ironport sprang up to create the spam cannons that began showering the internet with unwanted advertising messages. Yes, indeed, in 2002, a lot of the spam was actually sent by fairly legitimate-looking people. At this time, the first regular expression-based filters were being developed, and the semi-legitimate spammers were getting past the filters by obfuscating keywords in their messages, like, for example, substituting a 1 for the I in Viagra, the classic spamming obfuscation. The anti-spam industry responded by developing the first heuristic or rule-based filters, which combined the results of numerous regular expressions to glean whether a message was spam or not. Brightmail and ActiveState sold 2 of the first commercial spam filters, and of course Spam Assassin was getting underway at that time as well in the open source world. In 2003, spamming suddenly got very serious. I remember this particularly well. All of a sudden, email just started becoming unusable. Email marketing lobbyists went to Washington to make sure that legislators passed the Can-Spam Act. Why did they do this? Well, the Can-Spam Act makes it illegal to scrape addresses or to send email to people who have told you they want to unsubscribe. But it doesn't prevent so-called opt-out marketing, which means email marketers can still technically spam you at least once, and I'm sure you've all experienced that. Can-Spam isn't perfect, but what it did have the effect of doing was it forced spammers to go underground. It forced these legitimate people who were using Ironport boxes to become criminals or give up. Of course, when spammers went underground, the spam problem became worse because it forced spammers to move to less scrupulous jurisdictions like Russia and China, where the long arm of the law could not reach them. Spammers also started moving their sending servers around to avoid being blacklisted. And now, I'm Canadian, but I hear a lot about Ron Paul because I go to the Reddit site, which is, I think, 50% Ron Paul. But if there are any Ron Paul supporters in the room, they will agree that the Can-Spam Act created a situation analogous to the unsuccessful war on drugs. In other words, by making spamming illegal, we somewhat inevitably made the problem far more difficult to get a handle on. In 2004, spam volumes continued in their exponential rise. That year, Bill Gates famously pronounced that spam would be beaten inside of 2 years. People at Microsoft and elsewhere had devised 2 techniques that they believed would eradicate spam. The first was called Sender ID, or SPF, depending on which side of Microsoft you come from. The idea was promoted by some that Sender ID would allow for the creation of a permanent ironclad whitelist of domains that were guaranteed to never send you spam. So once everybody rolled out Sender ID, you could just whitelist the domains and spam would magically go away. Another idea that was pitched was the concept of a computational challenge, and this was an idea that really had a lot of traction inside Microsoft research. The idea was that senders would, when they connect to a receiving email server, have to answer a computationally complex challenge that would take a lot of CPU cycles to do. So if you were a spammer and trying to send out millions of messages, this would mean that you had to spend a lot of CPU cycles processing stuff, and therefore you couldn't send as much spam. Essentially, it would increase the cost of sending spam. Anyhow, neither of these ideas worked. At least they didn't work for the purpose of reducing spam. The success of real-time blacklists at blocking high-volume spam sources caused spammers to move in earnest towards the use of botnets. which provided them with an essentially endless supply of virginal IP addresses, and I hope I haven't offended anyone by saying the word virginal. In response, and I'm simplifying and generalizing a bit here, the anti-spammers assembled a larger and larger spam trap networks, collecting samples of spam and analyzing them at new 24/7 labs that were marketed to death. The spam trap systems made the blacklists even more responsive, forcing spammers to invest in even more intelligent and distributed botnets. I think you can see where the story's going. The history of spam gets rather boring after 2005, at least from my perspective. The story basically evolves into a stalemate, with the spammers pushing global spam volumes to well over the 100 billion messages a day mark, and anti-spammers able to achieve detection accuracies of roughly 90%, with false positive rates that they always claim are in the 1 part per billion or trillion range. By 2005, spamming was a fully criminal enterprise, with Russian gangs establishing well-organized hierarchical organizations comprising specialists known as botnet herders and virus writers. By this year, spam is generating an estimated $2 trillion a year in revenue. That's about the same amount of money that anti-spam companies make, so there's even an economic stalemate going on. If only I could figure out how to buy stocks in the spamming companies. And it gives you an idea as to the scale of the spam problem and just how intractable the problem has become. I mean, let's face it. If an industry is investing billions of dollars a year to fight some problem and it just keeps getting worse without any seeming end, there's a problem there. So to understand why spamming has become an intractable problem, let's take a look at the basic economics of spamming. Spammers make money if 1 in every 30,000 recipients buys something from them. And the numbers change depending on what's being peddled, but if it's pornographic spam versus stock spam, but 1 in 30,000 is a pretty good number. As it turns out, that is approximately the rate at which people actually click on stuff. Analysts estimate that spam filters are now on average 90% accurate across the board. Now I know that most of you probably have a better spam filter or a spam filter that's better than 90%, but if you look at all of the spam filters in the world that are in actual deployment, the accuracy on average is around 90%. So when a spammer faces a 90% accuracy level, that means that only 1 in 10 spam messages actually gets through to a recipient. Let's say we were going to move from 90 to 95% accuracy. Well, making that move would be very difficult for everyone to do. But let's be optimistic and assume that the entire internet rolls out better anti-spam protection and everybody is now running at a 95% accuracy. At this new accuracy level, spammers must send twice as much spam to have the same profitability from their spam campaigns. Well, that should be easy. Just light up a few more botnets, send twice as much spam, and you've beaten a room full of PhDs and an entire industry working around the clock on better filters. You can run the math for higher accuracy levels with similarly depressing results. And I have another presentation by a colleague of mine, John Graham Cumming, where he discusses how developing countries are now getting broadband internet and botnets are starting to appear in those countries. And anyway, it's going to get much worse. So what are these botnets exactly? In a nutshell, a botnet is a collection of compromised Windows computers known as zombies running special spamming software. The largest botnets contain millions of zombies and are now known by exciting names such as the Storm botnet. Botnets are controlled by a bot herder who uses sophisticated encryption and peer-to-peer networking techniques to ensure the resilience and permanence of his creation. For example, the most recent sort of press-worthy botnet, the Storm botnet, uses something called the Kademlia peer-to-peer networking system, which used to be used for file sharing, but now it's used for controlling botnets. Botnets are rented to spammers who pay the botnet herder to send out a spam campaign. I even heard recently that you can buy a network appliance from the botnet providers for about $3,000 that lets you control a botnet from a single box inside your colo facility. So the mail won't appear to be coming from your colo, it'll appear to be coming from the botnet, but you're controlling it through this box that you purchased from the botnet operator. The problem with botnets is that while the people who control them are constant, the individual machines that comprise a botnet are constantly changing. Spam doesn't come from a predictable set of computers, rather it comes from all over the place and is completely unpredictable. For this reason, naive techniques such as blocking have become less and less effective at getting rid of spam. As soon as you block one zombie, another pops up and sends you spam, and often you only hear from a zombie once. So to illustrate just how dynamic botnets are, this graph shows the number of times each zombie from the recent Storm botnet contacted one of our customers' servers. This graph shows that 40% of the zombies in the Storm botnet were seen only once. Fully 75% were seen less than 5 times. Clearly, trying to establish a reliable block list against such a botnet is a challenging proposition. Indeed, researchers at Georgia Tech discovered in 2006 in a survey of data from the Spamhaus blacklist that only about 5% of botnet IP addresses end up listed in the Spamhaus database. In a slightly earlier paper, Georgia Tech researchers found that 85% of spam zombies sent fewer than 10 email messages to their honeypot server over the course of 18 months. What this means is that there are lots of spam zombies your mail server has never seen before and probably won't ever see again. And just to explain what you're seeing on this graph, this is a sort of cumulative frequency distribution showing the number of times that a particular IP address was seen by the honeypot network that was in use at Georgia Tech. So as you can see, a lot of those IPs were only seen a handful of times. So here's a spam zombie your mail server probably hasn't seen before. It took the blacklist's 19 days to notice this zombie. During that time, most mail servers would have accepted email from this zombie, and then potentially they would have been able to filter out the content using a content filter. As I will discuss later in the presentation, we were able to get rid of all of these messages by slowing down or throttling the connections from this zombie, which caused the zombie to become impatient and move on to spam someone else. I'll get into that more later. But nonetheless, we must try to block zombies because if we don't, they'll completely destroy us. So I'm not saying that block lists are useless. If you don't have a block list, you're in really bad shape. If a spam zombie sends a lot of spam, it can be blocked relatively quickly, even within minutes. Essentially, as soon as the spam traps receive enough data from an IP address, in some cases just one message is enough, then we can add that IP address to the block list. Zombies therefore decay in their effectiveness relatively quickly, especially if the botnet operator uses a single zombie to send a lot of mail out. For this reason, botnet operators have virus writers working day and night to come up with new zero-hour vulnerabilities that they can use to recruit new machines into their botnets. But the point here is that, I guess, there's this perception out there that botnets are completely unlimited in supply and it's effortless for botnet masters to find new machines to spam from. It's not the case. There is a cost to recruiting machines into a botnet. For example, a virus writer in Eastern Europe gets paid about $100,000 a year. So there's some costs. Botnet operators only get paid by the spammer when a message is actually delivered to the receiving mail server. For those of you who understand the SMTP protocol, this means that the operator of the botnet gets paid only once the receiving server has sent a 250 OK after the data phase. So in order to make lots of money, both the spammer and the botnet operator have to send as much spam as possible from the botnet in the shortest possible period of time. If a zombie is being blocked, the botnet operator doesn't make any money. This is an important point, so I'm going to repeat it. Until a message is actually received by the receiving mail server, the botnet operator doesn't make any money. This slide caused quite a stir at this year's MIT Spam Conference, and I'll try to explain why. The spamming software that sends spam to your server from a zombie is impatient. Just like my 2-year-old, she's impatient. In programming lingo, spamming software has a very low timeout. The SMTP RFC recommends that email servers wait at least 3 minutes for each chunk of data to be received and acknowledged with an ACK from the mail server. Furthermore, the RFC recommends that receiving servers or sending servers wait at least 10 minutes for the final acknowledgement to come back from a receiving mail server saying that the message has been queued to disk. These long timeouts were established because back in the early days of the internet, networks and servers were much less reliable and much slower than they are now. And it really was the case that sometimes a server would take many minutes to copy the message to a vinyl record or whatever they used back then. Today, email servers and our networks are very fast, processing incoming messages in a matter of seconds. Delays still occur, but the timeouts defined in the RFC are vastly, vastly higher than that which occurs in practice. And thank goodness that they are. Since botnet operators don't get paid until they receive the 250 OK, their software earns a higher profit by disconnecting from an unresponsive or slow server and moving on to another server that is more responsive. Okay, I'm going to take a short intermission. I'm going to keep talking. You don't get a break from my talking, but I'm going to take an intermission because I've shown you a lot of slides, and at this point, when I was putting the presentation together, I thought people might be either pissed off or confused by now, so I better take a break to try and say things again. So a few years ago, the MIT Spam Conference was a very, very interesting place to be. Each year, bright-eyed graduate students and even intrepid industry types would present new filtering techniques that really pushed the envelope and pushed the accuracy of spam filters to new levels. For the past 3 years, the Spam Conference has been much less interesting. I mean, it's still interesting, but much less fantastic. A great result is a paper that shows an accuracy improvement of 0.5% or a performance gain of 10% or something like that. Spam filtering has really reached the limits of computer science. I mean, we're throwing everything we know about text classification at the spam problem, and the vendors have like 280,000 different things that they do to each message. Similarly, reputation systems which identify suspicious IP addresses have become asymptotic in their performance. The spread of botnets has led to a virtually, and I highlight the word virtually, inexhaustible supply of IP addresses which spam us a few times and then disappear forever. Most of the large anti-spam companies now have comprehensive blacklists that are updated around the clock. We are, in other words, blocking everything we possibly can, and yet spam continues to grow as a problem. It's almost unbelievable. So what can we do? Well, I mean, I'm a real fan of Bill Gates. You know, he's done some evil things in his career, but you can't fault him for having built the largest software company in the world that has never taken on debt and continues to make increasing revenues and profits every year. So when he predicted that spam would be eliminated within 2 years' time back in 2004, I really took pause and I thought, well, I wonder if that's going to be the case. Well, it wasn't. But I still believe that the concept that Bill was talking about 3 years ago was accurate. And the concept that he was talking about was that if we make spamming unprofitable somehow, then the spammers will go away. One way to think of the problem is that spammers have millions of computers. You only have a handful, and you have to pay for your computers. Who's going to win in any system that requires the sending computers to do some computation work? You're not going to win. But while we can't win the spam war with better filters or better blacklists, there is something we can do. We can still make botnets unprofitable. And how we do that is by slowing down spam traffic. The drawing on the left side of this slide shows how a typical email server deals with spam. And you can cut me down in the Q&A session for the inaccuracies in this drawing. Basically, zombies pour messages into the top. The mail server receives the message as quickly as it possibly can, and then a spam filter analyzes whatever remains and filters out the ones that appear to be spam. The problem with this approach is that as spam volume increases, so does the CPU required to process all of the mail. And as spammers innovate and become, develop new ways of encoding their spam messages, we have to write better algorithms that take more CPU cycles. So it's kind of this intractable death march. And as I've discussed, spam filters aren't really getting a whole lot more accurate now. So as spam volume goes up, we just get more spam into our inboxes. The drawing on the right side of the slide shows another approach to receiving email, and this happens to be the approach that we ended up settling on in my startup company. Basically, the idea is to block what we can, make sure that the stuff we know is legitimate goes through very quickly, and slow down everything else. And by slow down, I mean really literally slow it down in terms of TCP traffic shaping and slowing down our responses. By slowing down the zombies, we cause the spam software to time out and move on to more vulnerable targets. So one of the first users of our particular email traffic shaping system is a major pharma company in the United States. Last October, botnet activity was flooding this company's mail servers with so much spam that legitimate traffic was being delayed for several hours. They were using all the blacklists that they could find, including the blacklist provided by their anti-spam vendor. And by the way, their anti-spam vendor was actually one of the really good vendors, so it's not like they were using some crap product. But even though the blacklists got rid of 50 to 70% of the spam that was coming from well-known spamming sources, the spam that remained was still significant enough to be a huge drain on their servers. And it also ended up clogging their quarantine folders and even end-user inboxes to the extent that people were getting unhappy, and that's not a good thing. So being a commercially motivated startup company and an entrepreneur, and that means borrowing yourself into an unfortunate situation, we boldly proposed that they deploy our software in front of their mail servers to take some of the load off. I think because the problem was so severe, they were willing to take a chance on us even though we were a startup company and we didn't know much about marketing. When they started evaluating traffic control, and traffic control is the name of our system, in October, their spam levels went from 70% down to 20% overnight. As an experiment, they also tried turning off 4 of their servers. They didn't tell us they were going to do this, and when I found out, I became quite concerned because, of course, as the founder of a startup company and with considerable credit card debt riding on it, I had a lot riding on whether their CIO hated us for destroying their email infrastructure. But surprisingly enough, things held together well, and with just 4 servers, and to this day, that is the number of servers that they run to handle all of the incoming mail for their 50,000 end users. I just had breakfast today with this customer, and he says the system is still running with the 2 servers and spam levels seem to remain under control, but he also told me that his colleague is planning on deploying at least 1 more server, which does allow me to sleep better at night. Okay, trying to go to the next slide. Okay, I'm just going to take a quick break to see what's going on with my laptop. Okay, you can see that? Cool. So this slide might seem obvious to many of you, but I've put it up to help those of you who are perhaps confused, so please bear with me. That's not the slide I wanted. But it is a really interesting slide, isn't it? All those cars. Here we go. Slowing down spam traffic is something that has to happen right at the edge of the network. One way to do it is to deploy a network appliance with traffic shaping software. Another way is to deploy special software on one of your existing servers. We figured out how to make this work in software, and that is the way that our product is deployed. There is one other somewhat similar implementation of email traffic shaping, but it's deployed as a firewall box, and I'm going to leave it as an exercise to the audience to figure out what the other company is that does this. Now comes the part of the talk when I come clean and admit to a major problem. And that's why I put up this really nice picture that I found on Google Images. Slowing down traffic from spammers does work very well. It allows you to do something productive with the large proportion of spam traffic that isn't yet listed in some kind of blacklist. In other words, it allows you to slow down the botnets and force them to give up the ghost. The corresponding reduction in the number of email messages that must be processed by spam filters leads to a significant reduction in the resources that you need to process email in your organization. And it also reduces the amount of spam that ends up in quarantine or junk folders and in people's inboxes. Now, the problem with slowing down spammers is that as you slow down their TCP connections, the number of connections your mail server has to deal with at any one time goes up. It's just like a traffic jam on the highway. And by the way, this is a picture of Taiwan. I don't know whether any of you figured that out yet. You weren't meant to, but there you go. For example, at the customer I profiled a few slides earlier, they used to deal with maybe 100 connections at a time in their email infrastructure. And since we started slowing it down for them, they're now up at 500 to 1,000 connections at a time. That tenfold increase in the number of connections utterly destroys most mail servers. So I'm coming clean about that. To illustrate the problem further, consider that it takes between 1 and 2 seconds to deliver an email message to an email server that is running in a normal manner. When we slow down a spam zombie, our data shows that on average they hang around for 40 seconds. So obviously, if a significant proportion of your connections are lasting 40 times longer than normal, then the number of connections you have going on at any one time grows, maybe as much as 40 times. This graph shows the number of SMTP connections being handled by one server at a large university in the New York area, which is running our traffic control software. The text is a bit small, but for those of you with a zoom lens, you may be able to make out that the number hovers around 500 concurrent connections. The red line represents the total number of connections. The green line indicates the number of connections that are actually being slowed down at any one time. If any of you run SendMail or Postfix, you'll note that 500 concurrent connections is a large number. The amount of memory required to handle 500 concurrent SendMail processes plus any associated spam filtering is considerable. If we were passing this number of connections through to SendMail, the mail server would almost certainly die a horrible death. One approach to improve the scalability of email systems is to completely redesign your mail server with a new, highly scalable software architecture. But redesigning the mail server is very hard, and plus people are very attached to their mail servers. They don't want to swap out Postfix or SendMail just because you can get a bit of a performance improvement. The way we chose to solve the scalability problem was to come up with something we call real-time SMTP multiplexing. We built a sort of asymmetric SMTP proxy, and I'm throwing out as many computer science words as I can to help you guys understand. Our proxy accepts thousands of connections from the internet and then multiplexes these connections onto a much smaller pool of connections with the existing mail server. Unlike a mail server, our proxy doesn't save messages to disk, which means it's a lot less complex and also doesn't consume much in the way of system resources. And I look forward to answering your question about that will inevitably come up about won't you run out of memory. By multiplexing SMTP connections, we typically achieve a 5-to-1 or a 10-to-1 reduction in the number of connections that the mail server has to see versus the number of connections that are coming in from the internet. By reducing the concurrency of connections that the mail server has to deal with, we allow ourselves to slow down a really large proportion of the incoming connections, getting rid of a great deal of spam traffic in the process. This graph shows the number of connections to the mail server at that same large university I spoke of a few slides back. The red line indicates that the average number of connections with the mail server hovers around 50, which is well within the number of connections a typical mail server can handle. This is the Sesame Street analogy for those of you who, well, you all watch Sesame Street, right? Yeah? Okay, so now it's time for some interesting statistics. One of the things that we track in our software is the operating system type of hosts that connect to it. We use a tool called Passive OS Fingerprinting, or P0F, which analyzes characteristics of the TCP packets being sent from the connecting host to guess at its operating system type. The tool isn't perfect, but it does reveal a few interesting trends, which I'll share. The two pie charts on this slide show the proportion of connections which ended in a successful message delivery versus those which did not, broken down by operating system type. The big red zone in the chart on the left indicates that nearly half of the successful deliveries came from machines running Linux. The blue zone on the right shows that about 80% of the rejected or aborted connections came from machines running Windows, or I should say a consumer variant of Windows, something like Windows XP or Windows 98. The largest reason for an unsuccessful delivery in our system is when the SMTP client connects to us, is slowed down, and then gives up because they're impatient. These pie charts serve to confirm that Windows hosts running botnet software count for most of the connections we can reject using traffic shaping. And now for a brief analysis of the effect that traffic shaping has had on the so-called storm botnet. We obtained a list of IP addresses associated with the storm botnet and then correlated this list with our logs going back several months. Our logs indicated that traditional blacklists, and those are called RBLs for those of you that don't know, caused about 70% of the storm botnet connections to be aborted or rejected. Of the 30% of connections that remained, close to 75% did not end up completing a successful message delivery. We identified 10% of these hosts by their operating system type. In other words, they were running Windows 98 or Windows XP, neither of which are ever associated with legitimate email. So just to clarify, we were able to block 70% of the messages up front. Of the 30% of the connections that remained after that, we applied throttling to these, and 75% of them went away as a result of the throttling. When we looked at the connection durations of the SMTP clients involved in the storm botnet, we found that the overwhelming majority of these zombies disconnected within the first 10 seconds of the SMTP session. And by the way, we were slowing the SMTP session down to 10 bytes per second. It's as if they detected that they were being throttled and then disconnected so that they could go and spam someone else. I think that this is a really significant result because it reiterates that the economics behind the spamming business provide a huge influence on the behavior of spamming software. By attacking the economics of spamming, we can reduce its impact significantly. This afternoon, my goal was to educate you about the economic system that drives spamming behavior and how we can fight back against spam by interrupting this economic system. I began with a very brief history of spamming. Then I presented my theory of spammer economics, and I hope I answered the question, why do spammers continue to spam us? And finally, I presented a bunch of potentially interesting data showing how it's possible to really cut down on spam by providing behavioral barriers which reduce the profitability of spamming. If you have any questions, I'll open the floor for questions now, and I'll also mention again that there's a BOF session tonight at 8:30, and there will be free beer provided at the session. So you can take your pick. You can ask your questions now, or you can ask them later when you're inebriated. Go ahead.
Hello. It seems to me that you're trading on an edge case here, that since they own none of the machines and have no real vested interest in how long they stay corrupt, as soon as this kind of technique becomes even slightly standard across more than 1 or 2% of the mail hubs, the spammers will merely adjust the timeouts and the entire solution will disappear.
That's a really good point. And I get asked that every single time I do a presentation. My opinion on that is that this comes up frequently, especially at the MIT Spam Conference. Someone will present a new idea for fighting spam, and then immediately people in the audience will predict what will happen in 10 years' time when everybody has adopted that technology. And the truth of the matter is that even when new techniques come out, spammers take a very long time to adapt to them. For example, gray listing, which is basically the concept of rejecting a connection the first time you get a connection from a new sender you've never seen before, forcing them to try again later. Gray listing originally was about 50% effective at getting rid of spam. Now it's, after 4 years, it's down in the 20 to 30% range, but it's still quite effective at getting rid of spam. And when gray listing came out, people just, the first thing they said was, well, this is going to be defeated within a few months because the spammers will adapt to it. So I guess the first response to that is that spammers don't actually move that quickly to take care of new technologies. But I don't think that that's the best answer. I think the best answer is that if spammers were to adjust their bots to be more tolerant of timeouts, it would have the effect of ruining the profitability of their operations. Because each bot has a limited amount of resources that it can use for making connections and sending out mail. If a bot makes 10,000 connections at once, it gets noticed by the ISP. It consumes a large amount of bandwidth and it gets shut down immediately. So they have to tread this really fine line between having the bot fly under the radar and sending enough spam quickly enough that they make a profit. So anyway, my belief is that this technique will be useful for a long time to come because the spammers really just can't do anything about it. Worst case scenario, if everybody adopted this technology, and the bots were having to wait 10, 20 minutes, 30 minutes to get a message through. During that time, perhaps we could develop filter rules to catch the spam that they're about to drop on us, and then we could filter that spam out. We're already starting to see that. Some of our customers use CloudMark, the CloudMark collaborative filtering engine, and sometimes a new filter rule from CloudMark is available within the 5-minute period that a spammer is sending his message to us. So anyway, that's my 49 cents on that issue. I'll take one at the back now.
I was the senior internet mail administrator of America Online from 95 to 97. And trust me, in 95, there were plenty of people who really did care about spam.
Okay.
It was a serious profit issue then. But I'm wondering, the stats that we got from the spam workshop on Sunday were that at one particular small university, the year's stats for spam were, gray listing was 20% effective, but this month's stats 10% effective.
Right, so it's really fallen off
So
now.
it is really falling off.
Yeah.
And what we found at AOL was, at least for our community, we would spend 6 months working on a new technique to stop spam. And literally, over the weekend, the spammers would detect this, they would start working on solving it, and by Monday, new spam toolkits would be out and would be hit by them. So the other thing is, we found it makes a great deal of difference what your community is and how big of a target you are as to how quickly new techniques become less useful for you. And then the third thing I've got a question for you on is default targeting. What you're doing sounds like it's a little bit more advanced than that, but it seems to me like a simple solution would be PF plus spamd by default, and then whitelist any senders who make it through your initial tar pit. How would you compare that to what you're doing?
Actually, it's interesting. One of the customers that we have is a service provider, and what they do is they use PF plus spamd. So to just educate the audience a little bit, about 3 or 4 years ago, someone from the OpenBSD project created this little spam tar pit application called spamd that very, very efficiently and very, very slowly takes in messages from, or I guess accepts commands from spammers. And then at the very end, after many, many minutes of wasting their time, it simply says, sorry, I can't take your message right now. It gives them a 400 series response and goes away. So one thing you can do is you can hook up PF, which is OpenBSD's packet filter. You can hook that up to spamd such that the first time you see an IP address, essentially it slowly receives the message and then discards it. But then the second time or some subsequent time, it will allow the message to go through to the regular mail server, and the tar pitting thing is not even involved. I think the problem with that approach, from my perspective, is that it looks too much like gray listing. And the other thing is, it would have a rather high cost to new legitimate senders. If you discard the message from a new legitimate sender, some legitimate senders will try again, others won't. If you have a bunch of mail gateways, it's possible that, I mean, unless you make them communicate with each other and share their tables, that the gray listing will cause the sender to have to retry many times. And that kind of delay we have found is very unacceptable within a corporate environment.
You certainly have the gray listing issue, and the gray listing community has kind of the hard way found out which legitimate senders either send only once and don't ever retry, or like Yahoo, where they have outbound mail servers where the same mail server never touches the same message twice. So I'm just wondering if you could apply the same sort of solutions with a PF plus spamd tar pit.
That would be a really interesting project. As I mentioned, this customer does that, and they're looking at adding our stuff as an extra layer. So essentially, well, what they have done is they've modified spamd. So the stuff that they send to spamd is the only purpose spamd exists is to just reject messages all day. So they're just rejecting everything all day, and they've got PF in there to make sure that there's no loading on their regular mail servers. But there's still this huge tranche of stuff that does try again, and you don't necessarily want to receive it until that sender has developed a positive reputation. So throttling gives you something that you can do with that proportion of the traffic, and there's still a lot of spam that you can get rid of that way. Okay.
On your economic slide.
Sorry, on which slide?
On your economic slide.
Yep.
I think I must have missed something, because you were talking about it's the one where you're increasing your filter effectiveness to 95%,
Yes.
but the spammers double their volume.
Yeah.
It seems to me that for a given heuristic filter and a given message, a filter is either going to work or it's not. So it's binary.
Oh, I see.
It's a 100% or 0.
Okay.
And volume doesn't have anything to do with it.
Okay. Let me try to run through that one again, because I think it is important to get. And by the way, the idea for this slide is not mine. This slide came from John Graham Cumming, who did a talk in Europe earlier this year where he discussed this same concept. I have to get a faster laptop. There's that picture. That's why it's going so slow. Okay, never mind. So the idea is that if spam filters the world over are 90% accurate, then on average, when a spammer sends a spam message, there's a 1 in 10 probability that the message is going to be delivered to the recipient. Does that make sense? So I'm saying...
It depends on how you look at it.
Well, I'm saying on
average. If I'm the
average...
recipient behind the effective spam filter, my probability is 0.
If you're behind an effective spam filter?
If I'm behind one of the 90% of effective spam filters.
Well, if you're behind a spam filter which is 90% effective, then 1 in every 10 spam messages is going to get through to you. That's what I'm trying to say.
Okay, but that's looking from my viewpoint.
From the
spammer's
recipient's,
viewpoint,
yeah.
Either nothing's working or everything's working.
Oh, I see. From the spammer's viewpoint, they see their messages dropping in and they don't know whether they get delivered or not? Is that what you're saying?
I'm trying to understand under what situations doubling your volume, outgoing volume, will be effective in getting the message to anybody behind an effective spam
Right.
filter.
Yeah, you have to think of this in terms of like a, spamming as a big stochastic system. So, all of the spammers and all of the recipients in the entire world, if you assume that, I know that it's reality. The reality is that a spam message, if a spammer sends you 10 messages from the same campaign that your filter happens to know about, none of those are going to get through. But on average, across all time and all senders and all receivers.
The thought that just occurred to me is it's
Yeah.
because of the 250 thing, because of what they're getting paid.
Right.
It's basically,
Well,
they don't care as long as they get the 250 who it goes to.
Well, yeah, the spammers, first of all, the spammers test out the filters, so they know that when they send to iron port machines, it's like 96% accurate, and they know when they send to proof point machines, it's X% accurate. So and they also know because they're measuring the performance of their spam campaigns. If people click through, they get reports, and they know, okay, we generated $1,000 per million messages this week or whatever. And if they see the number going down, they just send more mail to top up the number. And the number usually goes down because the filtering companies have become better at blocking them for some reason. That's all I'm trying to get at.
Yeah, thank you.
Okay.
Yeah, the question, you talked about more about the economics of the anti-spam solutions and that. I got the impression that based on your economic model, there's it's either an all or nothing. Once they hit a certain point, they're going to go away. But I would almost argue that it's going to be, if you double the cost of delivering spam, that's still, the profit margins are incredibly high right now. You're just going to cut into it. If you cut their profit margin by 50%, it's still a profit margin. So would it be more advantageous to some extent to skew the economics by like doing an accept and dropping and discard the message right away where they think they delivered it, and it would skew their economics.
Right. This is a rather fine point. First of all, by slowing down spam traffic, you're doing more than doubling the cost. It's more like a 40 times increase in the cost, if you just look at the average time that spammers tend to hang around. But if you slow a message down to 10 bytes per second, you can work out how long it takes to get that message through. If a typical spam message is 1K in length, then it takes 100 seconds to get that message through. If it's an image spam or something, it might be 10K, so it takes a whole lot longer. So what used to take 1 second might take 5 minutes or 10 minutes. Now now the number of spam messages that you can force from your single zombie into a single receiving server drops by hundreds of times. That's a really significant interruption of the economics, and that's why, I mean, I'm just looking at the data. When we slow down connections, they do go away. And in fact, after someone has been running throttling for several months, there is this tendency for the number of inbound connections to drop off, as if the spammers have noticed that it's not even worth connecting to that domain anymore.
Have you looked into any of the work that's done, like in SendMail, they had the greet pause feature and analyzed that? At least that's what we're using at the university I'm at. We're finding now that after 6 months of it being implemented, it is almost blocking nobody.
Right,
anymore.
Interesting. Well, yeah, you have to block people for a long time. The default that we use is to block, or is to slow down for at least 5 minutes. Mm-hmm. And still, most of the spammers go away within 10 seconds. But there's it's a sort of long tail phenomenon. So some of them hang on to the bitter end. I don't know why. I don't know. I hear differing reports on the effectiveness of greet pause. The problem with greet pause is that if you want to make the greet pause long enough to really make it effective, then the number of connections starts to back up, and SendMail can't deal with lots and lots of connections. So for that reason, you're kind of constrained in the amount of delay that you can introduce.
I'd be interested to discuss more about that. We haven't seen that problem where we can handle at least 1,000 open connections at once on a server, and it's not really been a problem for us.
That's very good. Very interesting.
Oh, thanks.
You mentioned that 90% of connections would drop after 10 seconds, if I'm not mistaken. Do you have any idea how many of those connections that were being dropped are actually legitimate connections coming from misconfigured servers?
Oh yeah, absolutely. Yeah, and when I compiled the data for the MIT spam conference, I looked at the logs manually and did a statistical review of the data, and we know that the messages that were being aborted were spam messages. That's how they were classified into that particular class. Yeah, I'll take the guy at the front again.
Hi, my naive question is about the economics of getting ISPs to cooperate in reducing the effectiveness of botnets. If I could go to the head of the FCC and shake him by the shoulders and say, find a way legally to mandate home ISPs to block or vastly reduce the number of outgoing port 25 connections, would that work?
Well, I don't think so. I mean, a lot of the major ISPs in the US are now doing that. In Canada, both TELUS and Shaw, which are two of the largest providers, now block port 25, and that has definitely, eliminated spam coming out of those organizations directly.
Okay.
But the problem is that the United States is only a small part of the broadband universe, and there are these new islands of broadband access that are growing up in places like China, Vietnam, India, and they're growing like at a crazy pace. And the number of users who are going to have access to broadband in the next 10 years will utterly dwarf what we have here.
Right, but there are only 190 countries in the world. It's not impossible to go around, and it is scalable to implement this worldwide.
Yeah, that would be great if everybody could block port 25. I've talked to people at Time Warner and Comcast about this on a number of occasions, and I can't remember if they've done it yet.
So it sounds like ISP is doing the right thing rather than whoever the communications regulator is mandating it.
Yeah, but the problem is
Are there any examples of countries doing this at a government level?
Gee, not that I'm aware of, but I haven't really researched that. The problem is that for the ISP, there's no economic benefit for them to shut off port 25. In fact, it's a cost. Because if you can imagine, like imagine if Time Warner suddenly shut off port 25. Yeah. Everybody who uses port 25 to connect to their office mail server now has a customer support call that they have to dial in. And every customer support call costs $40. Mm-hmm. So the day you shut it off, you lose like hundreds of thousands of dollars in customer support calls, and people hate you and they move to a different operator. Where's the incentive?
This is why I want governments to do it.
Sorry?
This is why I want the government to do it.
Yeah, sure. But the ISPs have lobbyists as well, and they'll say you can't do that, because it's free enterprise or whatever. Okay. Net neutrality, who knows?
The question I've got just occurred to me. Spammers are inherently liars, as are botnet herders. So why would they get paid for every 250 OK? Why wouldn't they just lie about the number of 250 OKs they get and take your money and go away?
Well, did you ever see The Godfather? I don't mean to diminish your point, but the spamming world is an organized crime world, and there are other ways of enforcing contracts in the organized crime world. So, yes, I would say, while they don't have to be honest as we are sort of in the legitimate world, they have other ways of enforcing their contracts, and they do a good job of it, as I understand. I mean, if you're a spammer and you rent a botnet and you discover that it's not creating enough money for you, you're going to go and find the other botnet operator down the street and buy services from him. Or you might go and shoot him, I don't know.
Thank you.
Hi, I noticed you had a very convenient slide where you, before it got to your system, had already separated the mail into bad, suspicious, and good. And I'd like to subscribe to that newsletter, whatever that is.
David laughed in there too. That was a good joke.
But I guess if you do incorrectly, if the system does incorrectly assume that a legitimate mail server is suspicious and throttles them, all I see from my end is, instead of a call that says, I'm getting too much spam, I'm going to still get calls that say, I'm getting spam, in addition to calls that say, my email took 15 minutes to get through. I've already got users who complain when they hit the send button and it doesn't, there isn't any quantum entanglement and the message doesn't, instantly appear on the other person's computer. How are you justifying 5 to 10 minute, from what I can tell, slowdowns?
That's another great question. Well, first of all, we do our best to not throttle people who we know are legitimate. And so that situation doesn't happen very often. Second of all, in the case when some server is, like, let's say, some company lights up a brand new mail server, no one's ever heard of them before, maybe our policy, and this varies by customer, maybe the policy is to throttle them. The usual worst case scenario is the message takes 5 minutes the first couple of times, and then once the system notices that it's not sending, that people aren't sending spam, it adjusts, and then that IP is essentially whitelisted. So we don't get reports that people are pissed off about a 5-minute delay in email delivery. And I think that is because as the system runs over time, it learns enough about who it should whitelist that mail doesn't get delayed. The other thing is that people have this assumption that internet email is slow sometimes. And while, of course, in a perfect world, we would never slow down legitimate senders, it's going to happen. The other way of looking at it is that if you deploy an extra layer of traffic shaping in front of your email filter, it allows you to get rid of a lot of the spam without looking at the content. What that means is that you can actually tune your content filters to be less aggressive. So there's a lower likelihood that a message will be stored in the junk folder as a false positive. And that, we have found, has more positive benefits. So,
And do you see, as far as the economics, if a spammer isn't successful on his spam campaign with 1 million zombies, the economic incentive for me as a spammer would be to move my exploiting tactics from zombie machines to major corporate mail servers?
oh, absolutely, and we're seeing that. I mean, that's been going on for a long time. The problem or the challenge with exploiting legitimate outbound servers is that the people who run the legitimate servers, when their machine gets blacklisted, they take action instantly because it's such a disaster. So I would say that we are not so much creating that problem as the blacklists are, because if you get a bunch of smart zombies inside Pfizer's network, as happened recently, and Pfizer's outbound mail is blocked by millions of organizations around the world, the sysadmin tends to fix that pretty quickly.
Thank you.
Back there.
I'm an independent consultant, and I'm usually happy if I can convince a client that anti-spam efforts or an anti-spam solution is really all about just convincing spammers that there's easier prey out there. Please move on. It's never about having a clean email system. And I've probably done a lot more work fixing broken anti-spam solutions than ever implementing a new one from scratch that was clean. And so maybe this is too commercial of a question, but how much are your appliances, and how much do you charge for your services for ongoing support? Because obviously you can't set it and forget it.
Right. Well, yeah, it is a pretty commercial question. First of all, we don't sell appliances. At least we don't yet. I mean, if 10 of you asked for an appliance, we'd probably cook one up. But we don't sell appliances. Ours is a software solution, so it just runs on Unix, and we have a virtual appliance that we sell to people who are really just incapable of installing software, which is fine. Not everybody is a Unix hacker. In terms of cost, we charge about what the anti-spam companies charge for a filter. So if you can get an idea of what the pricing is for a filter, we charge about that, the same amount again. Yeah. And it's really, like, it's not for everybody. Not everybody wants to have a second layer in front of their mail server. Some people just want something simple that's all in one. Some of our customers only use our product, and for them, we can put in an optional filter from CloudMark that will do all of the filtering plus the throttling all in one place in a sort of really simple package. Anyway, there you go. We'll do whatever. We're a startup. Okay.
So with your explanation of the economic model, the pinch on the spammer is coming from the killing spam at the front door, not accepting it into the queue, and not doing post-processing. And it kind of indicates that folks that are doing a lot of post-processing aren't they're contributing to, I mean, they're getting a 250. As far as they're concerned, it's delivered. Do you have any sense of what, because they clearly don't care if the mail gets to an eyeball. They care if it gets to an eyeball, because if somebody clicks on something and purchases something. Do you have any sort of sense of that bit of the black box? Spam that's being delivered, but it may be delivered nowhere, versus how this ultimately ends up for money to the spammer, which is that somebody purchases something,
Right,
because
right.
some tiny percentage goes to an eyeball.
Well, the amount of money that a spammer makes is dependent on the clicks, as you mentioned, or it could be based on, if they're sending out a stock spam message, it could be based on the activity that they're undertaking in buying and selling some stock. But they measure the amount of money they make with each campaign, and so therefore they can measure the effectiveness of whichever botnet they use. So it's as though, from the spammer's perspective, he doesn't care whether there's a 250 okay or not. From the botnet operator's perspective, it's important, because if there isn't a 250 OK, it's guaranteed that the message didn't get through. If there is a 250 OK, then there's some chance. They know there's some chance that it got through to someone's mailbox. So more and more organizations are trying to push more stuff, more intelligence out to the edge so that they can send back an inline negative acknowledgement to make sure that the spammer understands that their message is not going to get delivered. At the back.
It's more of a social question than a technology and may not be applicable here, but one thing I've noticed since putting in a more effective filter is that a lot of users, because they're getting less mail, because the spam's going away, thereby assume that they're missing mail, and that somehow they can never tell me like specifically that, oh yes, I'm missing this message. It's always, I think I'm missing mail. I was wondering how you deal with that, and also people who believe that if there's some mail problem anywhere in the chain because there's a spam filter, it's your spam filter's fault. And what your thoughts were on that?
Right. Well, I mean, we don't get many complaints about our system, so yeah, maybe people are blaming the filter. I guess that would be commercially advantageous to us. Gosh, you know, that's not one I've heard before. I suppose, yeah, I suppose people might assume that if they're not getting as much mail, then they must be missing out on legitimate mail. If the world got to that point, I think that we would all be very fortunate, and you should be happy with the filter that you have in place. Are there any other questions at this point? Oh. At the back, do you want to ask one more question? We have time.
So I've been thinking this one through, and I'm not certain I understand all the angles of it. How does slowing down the packet flow differ from delaying the last 250 response?
That is a fantastic question. We wondered this as well. In fact, when we started developing the software 3 years ago, the first thing we did was just to slow down our responses. The problem with that is that the spammers will jam into the TCP window. As soon as they hit data, they jam the entire message plus the terminating dot into the TCP window, and then they disappear. So what you have to do is you have to play with the TCP window parameters such that they can't do that. They literally can't force more data into the TCP connection. They have to wait for the axe to come back from the stuff that is slowly being processed. And that forces them to hang around long enough to receive that acknowledgement from the mail server. So yeah, sending back slow responses doesn't quite achieve the goal.
How does it differ in effectiveness is the question I'm asking.
Right. Well, I don't know. I don't have an answer to that question because we've never deployed that technique in a commercial setting. But it would be a very interesting thing to look at.
Because yeah, part of me says, as long as we can slow down that 250 response, assuming I can't interface other changes with the mail server, but I can do it, let's say in Spam Assassin or something that's interfacing very late. Just wondering how, if you knew there was a reason that would not be effective.
Well, there's a couple of considerations. One of the considerations is that by slowing down or by adjusting the TCP parameters, you can actually conserve network bandwidth. That might not seem like an issue for many of you guys because you're used to just having like OC 192 available at your fingertips. But for a lot of companies, they literally have T1s supplying their email servers. So if they can cut down their traffic by 50%, it makes a big difference. So that's one consideration. The other is that regardless of whether you're just delaying responses or delaying responses along with adjusting TCP parameters, when you slow things down, you increase the concurrency, and that causes problems for a lot of mail servers. So you have to deal with that problem regardless. And your question?
Yeah, you mentioned it in your talk. How do you handle the queuing of the mail on your appliance talking to the back-end mail servers if you're not running the disk? How are you compressing it or squeezing it into memory, or what are you doing?
Right. Well, you know, we thought initially in our engineering plans, we thought, okay, we're going to have to address this memory consumption issue because one day it's going to happen that there are so many concurrent messages that we're going to run out of memory from having all these messages slowly going into RAM. And so we had this, we had this plan. We're going to add this feature that does something when the memory is about to be run out. But we've never encountered it in practice. Even at sites that do 6 million messages a day, a server with a gigabyte of RAM has plenty of memory to handle all of that traffic. And the reason why you don't need that much memory is because, generally speaking, the amount or the number of messages that are really large that you have to handle is quite small. And generally, really large messages come from legitimate senders and they pass through really quickly. So they have a very small sort of temporal impact on your RAM usage. Spam messages tend to be much smaller and you throttle them. So that means that even though you might have 1,000 connections, there are 1,000 connections that could take no more than about 10K worth of memory. 1,000 times 10K, what is that, 5 bytes? No, I can't multiply right now. It's like 10 megs or something. So we see process sizes not exceeding about 100 megs.
All right, thank you.
You're welcome. And one more.
Since you're picking on Bill Gates and his crystal ball, how do you predict IPv6 will impact abuse technologies, and on what timeline?
Well, IPv6 will be introduced next July around the world ubiquitously. And honestly, I'm extremely concerned about IPv6 from an abuse perspective because the profusion of address space is so absolutely alarming. I mean, already we're seeing, and there's another talk tomorrow on this topic, which I really suggest you go and see. Is it today? It's right after. Oh, perfect. So stay for that talk. Spammers are starting, or botnet operators are starting to hijack BGP to create brand new blocks of IP addresses out of thin air, and then they send spam from within that new IP space. Essentially, they can tunnel traffic from a bunch of bots into that new IP space, and then all of a sudden you've got spam coming from IPs no one has ever seen before. And there's some other research that was being done, I think, at Georgia Tech, where they showed that these blocks can last for 2 minutes. So there'll be a new block of /24 or /16 that's announced. A bunch of spam pops out of it. 2 minutes later, the route is gone. You don't even know where it came from physically. And so hacking Cisco routers is now something that the botnet operators are really interested in, because when they hack a router that is trusted by others in the BGP system, they can all of a sudden create IPs out of nowhere. I'd love to be a spammer.
I believe those are called bogon routes.
Pardon me?
I believe those are called bogon routes.
Oh,
they're routes out of the bogon network IP address ranges that have never been issued to anyone.
Yeah, but
and
they're
there's
also
the
announcing
Team Kimru bogon filters.
Right.
I'm real interested to see why that's not just a simple solution to this problem.
Right. Well, the way I understand it, I'm not an expert. The next talk is an expert, but the way I understand it is that the spammers are announcing, they're announcing IP address space that might actually not be bogon. It's actually a legitimate IP space. It just happens to be unused. And there's a lot of IP space out there that's just not being announced actively. So if you announce it for a while, people will pick up the routes and then you can send from it. I believe it's even possible to announce IP space that is being announced elsewhere. If you get enough people to trust your routes, then you'll be able to send a bit of traffic from that space. But stay tuned for the next talk. If there's any more questions, stand up quickly.